I've had this job sent in by one of my viewers. What he wants me to do is weld that hole up, drill it and retap it 1/2 inch 28, which is UNEF. Luckily I have got a tap that size. The trouble is, if I go near this with a TIG set, apart from burning the finish off, there's a good chance it'll destroy the part. A much better way is to drill that, tap it, in that case 20 by 1.5, screw in and Loctite in an aluminium plug, then drill and tap that. Is 1/2 inch UNEF. So that's what we're going to do. Drill it, tap it. I'll just probably screw cut an aluminium blank, Loctite that in, and then finish the job off. Like I say, welding, you know, it is possible to weld it up, but it'll be a lot easier to put well, not easier, it'll be a lot neater and tidier to put in an aluminium plug. I don't want to grip it on the threads, obviously. That's better. Right, that's running reasonably true. 18.5 is the hole size for the 20 by 1.5 thread. I haven't got a fantastic hole of this, so we'll just be nice and gentle. .5, bang on the money. You find most decent quality taps have got a hole in the back, and this is the reason for the hole in the back, so you can hold it nice and true using the lathe tailstock. I'm just going to do this by hand. I don't want to power it in case it tears the job out of the chuck. WD-40 type lubricant is the best stuff for aluminium. Putting a little bit of weight on the tailstock hand wheel. So I'm going to back it off just to help break the chips. Cutting a nice tight thread. Right, that's it all the way through. So if I spin the lathe up, it's by hand. So the end of the tap is running nice and true. That means the threads have got to be nice and square. 20 by 1.5 might seem a strange thread, but it's a very popular thread in the motor trade. 1.5 metric pitch is really popular on car stuff. See, then we've got some nice clean sharp threads. I mentioned I'd getting some tips for machining aluminium and what a difference I've actually made. Still with a cent eight, that bastard. It's actually breaking the chips. Instead of just tearing it off, it's cutting it properly. And there's no sign of the chips sticking to the tool, which is what normally happens. The weld ourselves on, and then you have all kinds of problems. Right, 20 mil. Just something for the tool to drop into. This is a 20 by 1.5 commercial tip, dead on centre height, and that makes sure it's at 90 degrees to the job. I've got the gearbox of the lathe set up to cut this thread. It's a 20 by 1.5 thread pitch gauge, spot on. These are stuck when I did. It feels slack, but it'll lock tight in there. No problem at all. A little bit of brake cleaner, make sure all the oil and residues off there. That's the stuff I use. Once the stuff goes hard, basically that's it. It ain't coming apart. But saying that, you can use heat, and then it will come apart with heat. I've turned it around in the chuck. It's sort of ready to part off. I'm just going to put a centre in, just to give it a little bit more support. Like I say, we haven't got a fantastic weld on it. Just a tiny amount of weight just to hold it. Parting tool in there. Nice and gently. The tapping drill for this thread is 15-30 seconds of an inch, and I've actually got a taper shank drill. We'll put that in. I've seen sharper drills. Look at the state of that bastard. It's been ground the wrong way. better. That's kind of what it's supposed to look like. Could do a little bit more, but it'll certainly do the job. Right, that's it. 1/2 inch UNEF. I'll just put a little chamfer on that hole. I should have done it before I put the tap in actually. Happy with that, very happy. One more off the list. Unfortunately I have damaged it, but I'm sure it'll still work alright.